Yes. A pencil? I don't have an extra pencil. Anybody have an extra? Oh, wait, hold on. I do. Well, it's not mine. Well, it's not sharp. You need a pen? I have a pen. I don't. Yeah, but it needs to be sharpened. You want a pen instead? Do you care what color? Let's choose. Okay, so we do have an exam. Did they all get passed around? Everyone got one? We do have an exam. It's on Wednesday. Now, normally I would give you a review a little earlier than this, but this first exam is over review topics. So if you've been doing your homework, I think if you look at the review, everything's going to line up with what you've been doing for homework. And with the exception of problems, well, the front page you should be able to do. The back page is what we're going to talk about today. All right? So let's see how far we get. Hopefully if we get far enough, then we'll be ready. If for some reason I don't get as far as I want to, then I'll tell you, what problems to not worry about on the exam. All right, so let's get going. So we stopped. We had this picture here. Okay, so we need to talk about factoring. So factoring is one of those things that always cause students trouble, factoring. And when it comes to factoring, there's like a set of steps to factor something. And all we are going to look at today is whether or not you know how to do the first step for factoring. All right? So later on when we do more factoring, I will give you a set of steps. And the first step will always be this step. So let's just make sure we all know how to do this step. And that is doing what's called the factoring out what's called the greatest common factor. So the whole idea here is this. You're given an expression, okay? And it has pluses and minuses between these things. These are called terms. So we have addition, subtraction, right? Addition, subtraction, subtraction, addition, addition. So whenever you have these terms split up with addition and subtraction, what you're trying to do is turn it into something that has multiplication instead of addition and subtraction. That's what factoring is. So the first step is called factoring out the greatest common factor, or you'll see people refer to this as GCF, greatest common factor. Oh, it's written right there. And so what you do is, well, can somebody tell me what to do? How you do this? Go ahead. You first start looking at numbers, okay? So you look at these numbers, you have a 6 and you have a 6. And so you ask yourself, what number divides into both 6 and 6 evenly? So what's the biggest number you can think of that goes into 6 and 6? 6 itself, right? So 6 would be part of our common factor. So we put 6 here. And then you start looking at the letters. And you say, do these two terms have a letter in common? Do they both have the same letter in common? No, they do not. So we're done. We're not done, but we're done factoring out the greatest common factor. Now after that, we put a set of parentheses. And what we want to do is make this parentheses big enough to fit 2 terms in here. And the reason there's going to be 2 terms in here is because we started with 2. If this were 3 terms, I want to give myself enough room for 3 terms. So now what we do is we imagine that if we were to distribute this 6 through like this, the 2 pieces in here would have to give us back these 2 pieces. All right? So what would I have to multiply 6 by to get 6y squared? Just the y squared, because I already have a 6. So I put y squared here. And then there's a plus here, right? So I'm just going to put plus. Now what would you have to multiply 6 by to get back this 6? 1. And that's it. That is the answer. So the good thing about factoring GCF is you can always check your work, right? Like you can just multiply this through now. This times this is 6y squared. This times this is 6, and you would get back this. But notice that I have turned it into multiplication. See the multiplication right there? I've turned addition into something that's 2 things multiplied. Now, I understand there still is addition here, but we have multiplication also. All right? So then we do the same thing on number 12. So let's start by looking at numbers. Are there any numbers that go in? Well, what's the number on this one? 1. There's a 1 here, right? So is there a number that goes into both 1 and 3? Just 1 itself, right? That's the only number that goes into 1 and 3. So we could put a 1 out here, but normally when we factor, we don't put 1. We just don't put anything. All right, so we just keep going. Now we look at letters, variables. This one has an x. Does that one have an x? No, so we can't pull an x out. This one has a y squared. The other one also has y squared, so that's a common factor. So I can put y squared out here. Then a set of parentheses and enough space for how many? 2, so that should be enough space for 2 terms. All right, and then we kind of play this game. We say, what would we multiply y squared by, right this, to get back xy squared? So what's missing? Just x. And then on the other one, I'll do minus, and then y squared times what would give us 3y squared. So we're only missing the 3, so we just put 3. And that's it again, we're done. Does this look familiar? Yes? Anna? Yes? Where's Anna? How you doing, Anna? You want to do the next one, Anna? Okay, so tell me, Anna, in terms of numbers, what, 3? Right? So 3 goes into both of these. So I pull out a 3. And then, Anna, how about the variables? Just one factor of x, okay? Because this one has x squared. That means there's 2, it's like x times x. This one has just 1x. So you can only pull out what they have in common. And what they have in common is just 1x. Does that make sense? So we put x out here. Are we done, Anna, pulling out the GCF? Open parentheses. Enough space here for 2. And then what goes in there? X plus 2. That's it. We're in business. Good. All right, this next one looks real bad, right? Because it's all a bunch of terms, a bunch of letters. Skylar? You want to do it? What number do we have in common? Okay, I'm looking. Yeah, it's Monday, and I'm already bad with names, so we'll see how this goes. Skylar, all right.
Can we do 16 all the way?
Okay, so let's think about this. 16 definitely goes into 16. Does 16 go into 28? Right? It's not, doesn't quite go in. If that were 32, it would, can't do 16, but maybe there's another number. 2 would go, right? Because they're all even, right? 2 would go. So we know 2 would go for sure. So what I recommend is 16 was too big. 2 will work, but let's try and get the biggest number. So let's try something else. How about 4? Okay, so 4 would go in here, right? 4 times. 4 would go in here 7 times. 4 would go in here 12 times, right? So 4 would also work. Is that the biggest number? Well, what would be the next number we could try? 6 would be the next number we could try, but 6 doesn't go into this. How about 8? 8? Yes, 8? No, right? So 8's not going to work. I'm only trying even numbers. Why am I only trying even numbers? Because all these numbers are even, so an even number has to be able to go in. If it's going to go in, it's going to have to be even. Let's see, 10, 12. 10 doesn't go in, right? Okay, 12 doesn't. 14 doesn't. And we already tried 16 would be the biggest. So 4, was it 4? Right? 4 is the biggest number. Now, you could have pulled 2 out.
Yeah, that's what I was going to ask. If we had chosen 2, would it have messed it up since it's not the greatest?
It would not have been the greatest. So you would have had a 2, but then everything inside here would still have a common factor of 2. So you would be like partially there, but not completely. It wouldn't be the greatest common factor.
Right, so if you were asking, like, if this was a question and you asked me for the greatest common factor, it'd be wrong, right?
It would be partial credit, but it would not be completely correct. That's right. Okay, so 4. All right, let's go with someone else. Good job. Samantha? Letters. Let's start with the x's. What is my, do I have a greatest common factor with x? No? Why not?
There's no x in the 40.
Yeah, there's no x here, right? So if you have x's here, that's great, but if you need to have an x here to be able to pull an x out, right? All right, how about y's?
Y squared.
Y squared. They all have y squared. So I'm just going to pull y squared out. And we are done with the GCF being pulled out. How many terms do I need to fit in here? 3, so I'm going to make my parentheses pretty big like that. And then Hayden? Hayden? No Hayden? Colby? All right. What goes in here, Colby?
So can I
Just read it out.
all right, 4x squared
Uh-huh.
minus 7x
Yep.
plus 12 y cubed.
Y cubed. Okay, good. So, you know what? When I was looking at this a second ago, I didn't even realize that was y to the 5th. I thought it was y squared for some reason. So I should have mentioned that when we pulled out y squared, this had 2 y's, this had 2 y's, this had 5 y's, so we pull out only what they have in common, which is why we only pull out y squared. But then you need y to the 5th out here, I'm sorry, y cubed out here, so that when you multiply this times this, you get y to the 5th. And just remember, when you do y squared times y cubed, you get y to the 5th. What would you have to do to get 6 here? I've seen people get confused on, do we add these or do we multiply those? Does that ever confuse you or no? No, you're okay with it? The only way to get y to the 6th is if you do y squared cubed. If you do y squared and then that cubed, that's how you get y to the 6th. See the difference between these two? Here you add the exponents, and here you multiply the exponents. All right? Okay, this is it. That's our answer. We good? Questions? Okay. Gabriella? Gabriella? I had a feeling there would be a lot less of us here today. Liliana? Okay, Liliana. On this next one, start with a number. Do you see something, the greatest number that goes into all of those? Five? What do y'all think? 5? I think 5 looks good. Yeah, let's just go with it. So 5. Here's the thing. Let me show you on this one. Can I show you back on this one? Let's say we had pulled the 2 out. Okay? If we had pulled the 2 out, we would have had 2 here. What would have been here? If we had pulled 2 out? 8. And then what would have been here? 14. And what would have been here? 24. What we could have done is at this point kind of looked again and said, oh, wait, hold on. We missed, there's another 2 here, right? 2 goes into this, this, and this. Pulled another 2 out, and that would have made it a 4, and then it would have worked. So if we pull a 5 here, and we're not sure, we'll just at the end take a look again and make sure there's no other number that comes out. All right? So let's pull the 5 out. Do you want to keep going, or in terms of the x's, how many x's you can pull out? So this has how many x's? 3 of them, 2 and 4. So you can only pull what they have in common, which would be 2. So the least amount that shows up in all of them. X squared? How about y's? Y cubed, right? Y cubed. So you have 4 of them, 5 of them, 3 of them, so y cubed. Enough space for 3 terms. And now Andres. Andres? No? Okay. Emily? Wow. I have the right class here? Yes. Savannah. Okay, Savannah. Sorry, Savannah. You okay? Go ahead. What do you got? The first term, what do you have there? 5 xy. Okay, good. So everyone, 5 times 5 is 25. X squared times x is x cubed, and then y cubed times y is y to the 4th. Good. You want to keep going, Savannah, or you want to pass it off? I don't care. Pass it off? Okay, who's up? Pepe. You get the next piece. 13. Y squared. You can say y squared, right? Okay, now you said 15y squared. What goes here?
I said 13.
Oh, 13. Okay, sorry. I heard 15. Okay, what goes here? Minus. Okay, so subtract. Everyone good with that? We need a minus there. And then another minus after this. And last, Valeria? 16x cubed. All right, does everybody agree with that?
Oh, wait.
No, squared.
Oh, squared, okay. All right, so when you do x squared times x squared, you're going to get x to the fourth. And then you'll have y cubed, which you just needed y cubed, so you don't put any y's there. Does this make sense? Okay. All right, so that is GCF. Let me see if there are any other examples here for us to do. It does not appear so. All right, so let's just look at the homework assignment for this. Hopefully you'll be able to handle this, and maybe you already started on it. Hopefully you did. You had that long weekend, so what else are you going to do on the weekend, right? Just do math, right? Okay, so these are operations with polynomials. So adding and subtracting, multiplying polynomials, dropping your parentheses. So we did problems like this in class already. And then we did some geometric problems. I can already tell you that your exam problem is going to be very similar to what's on the review. So if you can handle the review problem, we did one like it in class, you should be okay. And let's see. These are the GCF problems from the homework. So this is just like what we did just now. So make sure you look through those. Nothing there looks any crazier than what we've already done. And so now we're going to move on to percentages. So let's talk a little bit about percents before we actually get in there. So if I write this down, if I write 12% of people love math, then what does that 12% mean? So when we write 12%, because we see percentages all over the place, don't we? You watch the news, read some, they're always the same percentage. So what does 12% mean? Part of 100, is that what you said? Yeah, so when we write percentages, what this means is 12 out of 100. Okay, so 12 out of 100 people love math. All right, that's what that percent means. Now, here's what's kind of weird but yet interesting, I guess, about percentages. We're going to do a percent right now for our class. And I won't ask you if you love math because I don't want to put 0% up there, okay? How many of you own an iPhone versus owning an Android? So iPhone, see if we're 100%. We're almost 100%. Okay, so how many of you own Androids? That's me, I'm in that. So 1, 2, 3, 4. Okay, so we're going to say 4 Android. And is there another type out there? I guess we're either Android or, okay. Let's count the number of students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19, 20. Oh, good, nice number, 20 of us. There's 20 of us in here. So that means 16 are iPhone, right? Okay. So what percentage of uh-oh. I don't care about that. You just messed up our numbers, though. Do you own an iPhone or an Android? Tell me you don't own a phone. Okay. No. iPhone? Okay. Let's change it. All right. Let's change it. We're now 17, and now there's 21 people in here, right? All right. So what percentage of the class owns iPhones? So how do we do that? What percentage? I'm kind of asking, but I'm also asking because I want to show you how we do it, all right? So what we need to first of all figure out is we want to know the number of iPhones, and we divide that by, does anyone know? The total number of students. Total number of students. And that will give us a percentage. All right, that'll give us a decimal. Let's see what it is. Okay, decimal. So get your handy dandy new calculator out, or the one that you're supposed to have for this class, right? And we are going to just be doing, what is it? iPhones is 17 divided by total number of students is 21. And so 17 divided by 21 on your calculator, oops, I did 20, is, I'm getting 0.80952381. That's what my calculator is telling me. Okay? Now, this is a decimal, isn't it? This is a decimal. We need to know how to convert a decimal over to a percentage. So, everyone know how to do that? If you don't know, the way you convert a decimal to a percentage is you take this decimal point and you move it over 2 places to the right, and you place it there, and then you write a percentage symbol after it. So this is going to become, what, 80 point, I'm going to write it 952381%. So here's your decimal answer. Here is your percentage answer. Now, we don't need all those decimal points. We don't need all those numbers. So let's round this, all right? This is about how much? You could say 81%, right? You could say maybe 80.9, but 5 is supposed to make that go up by 1. So let's just go with 81%. That's good enough. 81%. So 81% of this class are slaves, our own iPhones, right? Yes? That's actually not as high as I usually see. I usually see in the 90s. But I don't know, lately it's been going down these last few semesters. So these are 81% of are iPhone. All right? Now, if 81% are iPhone, then what percent are Android?
19.
Yeah, we could do this computation again, right? We could do 4 divided by 21 and we would get the percentage. But you can also just think that it has to add up to be 100%, right? So it's just take 100% and subtract this, and that's 19%. So 19% are Android. All right. Now, the reason why this is important, or not important, but the reason I wanted to bring this up was because I just said here, or we said that 12% of people love math means 12 out of 100, right? So when I say 81% of this class, right, likes iPhones, I don't really mean that there's 100 people in here and 81 of them like iPhones or have iPhones. Does that make sense? This does not imply that there are 100 people in here and 81 of them have iPhones. This implies that if we were to take the proportion of students who have, or proportion of people who have iPhones, that if there were 100 of us in here, 81 of them would have iPhones. Does that make sense? So don't always look at this percent as being that that the population is 100. Yes? Sure? Okay. All right. Now, that's just kind of a quick introduction as to what percentages are, how they work. And now let's start solving some problems. This is a review. We have a test on Wednesday. All right, here we go. Anybody else need that review? I don't think I missed anyone walking in. Okay, take a look at this first problem. It says here, write each of the following as an equation and then solve. One of the problems that I see on the test for this is that students don't do the part of writing the equation. They just do a bunch of kind of chicken scratch math and they try and get an answer without actually going through the process of writing an equation. So when you see this problem right here, there are important parts within the words that you need to be able to identify and convert into an equation. So we're going to try and take a sentence and turn it into a mathematical equation. So the first thing is anytime you see the word is, just convert that to an equal sign. All right? Now, that means on the right side of the equation, I need 21. Do y'all see what I'm doing? I'm just kind of converting this to an equals. There's 21, right? And then when you see the word of, it usually means multiplication. So this is going to be, now I'm not going to write that little cross multiplication. I'm going to put that dot multiplication. And then I have 200 here. Do y'all see how I'm doing this? Now, what percent is the thing I'm trying to find, right? So when it says what percent of 200 is 21, then the what percent is what we're searching for, yes? Okay, so if this is what we're searching for, if this is the thing we don't know, then what are we gonna call it down here? X or anything really we want. I'm gonna call it X. All right? And have I accounted for everything in the problem? Is everything accounted for? So at the end of the day, here's what I've got. I've got X times 200 equals 21. And a lot of times when we write X and 200 like that, we don't write it this way. We usually would just write 200X equals 21. That means the same thing, right? X times 200 is the same as 200 times X. Just flip them over. We good? Now solve that equation. This is a little linear equation. We already have done a section on this. So how would you solve for X? Uriel? Where's Uriel? Uriel, yes. Uriel, I'm saying that too slow. How would you solve for X here, Uriel? If I'm asking you to get X by itself, what would you have to do? Divide by 200 on both sides. Good, right? Cancel this out. You have X here on the left, and then on the right side, we are not, now because we're in the percentages section, we're not going to leave our answer as a fraction. We're actually going to go to our calculator, and we're going to do 21 divided by 200. And I'm going to get 0.105. Now that answer, any questions up to this point? That answer is correct, but it is not the correct answer to the problem. Because the problem is asking for a what? A percent, right? And we have a decimal. We have to convert that to a percentage now. And how do we convert that decimal to a percent? Move the decimal point 2 places to the right. So if I imagine just moving this over 2 places to the right, I get what? 10.5%. All right? So what I like to do when I'm done with a problem like this is to come back here and just kind of cross this out and then put my answer here and then read it to myself again and see if it makes sense or not. 10.5% of 200 is 21. Does that make sense to you that that would be true? 10% isn't much, right? 10%? So if I say what's 10% of 200, my number should not be bigger than 200, right? What would 50% of 200 be? Half of it, right? 100? So you can kind of like get an idea, does this make sense? 10%, just 10% of 200 would be 20. So if that helps, great. If not, trust your answer, move on, right? All right, let's take a look at the next one. 15% of a number is 19.5. Calculate that number. Robert? Help me out, Robert. So What are the things we're looking for in here? The things I said, like first try and identify and start writing your equation? Is, right? So the is going to be our equal. Okay, what else? The of is multiplication, right? Okay, so I have multiplication here. All right, what about this 19.5? Where would I put this side, right? On this side of the equation, so 19.5. So do y'all see we're kind of just generating the equation right from the words? And then how about this 15%, Robert? How about this right here? So right here. Now, this is very important, everyone. When you're writing the equation out, you cannot write it in there as a percentage. You have to convert it back to a decimal. All right? So instead of writing 15% here, what would I write? 0.15. So when we go from a percentage back to a decimal, remember there's like a decimal point here. We move it to the left 2 to go from percentage to a decimal. When we go from decimal to a percent, we go to the right 2. So we're reversing what we just did. Last thing, Robert, I'm going to keep you on this thing. How about this? A number. X, right? We don't know what that is, right? So this is just X. Good. Good job. So now, end of the day, we have this. 0.15 times X, right? So X equals 19.5. And Thomas? What now? Solve for X. Divide 0.15, right? Divide 0.15. All right, and this is where you get your calculator out. 19.5 divided by 0.15. What are y'all getting? 130. 130. Now, do I need to convert this to a percentage? Do I need to do anything with it? Is it good the way it is?
No, that's fine. Set for a whole number.
Yeah, so it says we're trying to find a number, right? Not a percent. So whatever the number is what we're going to have as our answer. So this should be 130. And you can read the problem out to yourself again and hope that it makes sense. I don't know. 15% of 130 is 19.5. How about this next one? Let's see if we can do this next one. Try and get through all these sticks. Cameron?
Yes.
Okay. Number 3.
So is would be equals,
Okay.
and then 25 would be on the left.
Okay.
And 40% return is
0.4
and then of what would be times X.
times X. So can I just do that? There you go. That's it. So remember, on the test on Wednesday, I want to see you write the equation, all right? Write the equation out and then go through the process of solving it. So what would I do to solve this? How would I solve for X here? Divide both sides by 0.4. So divide by 0.4 here. You could say 0.4 or 0.40, it's the same thing. 0.40. And so I'm getting 62.5 equals X. So I can scratch out what, and I can put 62.5, and I can read it to myself. 25 is 40% of 62.5. Are y'all okay with this? Y'all feel all right about it? Okay. These are going to get more complicated, all right? So let's make sure we get these down first. These are going to get more complicated, and then also the way we solve them, we won't necessarily be able to write equations out for every single one of them. All right. Number 4, Michael? Michael? No? Tatiana?
For number 4,
Yes. If you want, you can just tell me what to write, like the whole equation, or if you want to just take it piece at a time, we can do it.
well, I'd say like equal to 200.
Equal to 200?
Not equal at 200 because we're trying to find the 35% off of 200.
Okay. I'm saying, how would we start writing the equation out?
I say like a 35% is at 0.35.
Okay, so you want to turn that to 0.35. Okay, that's fine. What does of mean to us?
Of 200, means you have to find the whole of 200.
But in terms of like mathematical operations, when we see of, we need to be thinking what?
Or like a division?
Nope.
Multiplication?
Multiplication. Okay, so of will always be multiplication. So this is going to be like 0.35 times, and then 200 is just 200. All right? Now, Tatiana, just because I want you to do well on the test, of is multiplication, right? Is always going to be equals, your equal sign, right? So that's going to be equals.
That must be sort of a confusion.
Is it clear now?
It's all clear.
Okay. And then what about what? What becomes what? Our variable x. Okay? So there we go. That's what we have. And now to solve for x, it's already solved for x, isn't it? All we have to do is carry out that multiplication on our calculators. So 0.35 times 200, 70. And so if we scratch out what and put 70 here, 70 is 35% of 200. Again, you think through that. Depending on how comfortable you are with percentages, that does make sense. Real quick on this one, let's just write this one out. I'm just going to read it from left to right. Ready? 35, what? Equals x times 200, right? To solve for x, we would do what here? Divide by 200 on both sides, and then whatever we get as our answer, be careful, whatever we get as our answer, we would have to do what with? Convert it from a decimal back to a percent, because it's asking for a percent. Did anyone do this one yet? 35 divided by 200? 17 point what? Okay, so 0.175 is what you get when you solve for x. And then you convert that to a percentage, so the answer to this would be 17.5%. All right. Let's move on. Let's look at number 7. I can't quite fit all that on here. Going to have to zoom out a little more. All right, can you all read that okay? So for a problem like this, you are not going to be able to just put a sentence together. All right, there's too much going on here. So let's see how we're going to attack this. 30% of all students at Northwest Vista College transfer to UTSA. All right, that's the first statement. Of these transfer students, 12% are going into biology. If there are 15,435 students at Northwest Vista College, how many will transfer to UTSA and major in biology? Does that seem a lot different than what we've just did? Yes?
Yeah, because it's the 12% of the 30.
Yeah, so you've got a lot of things going on here. It's not just like, what percent of this is that, right? It's not simple like that. We actually have to understand what's happening. So I like pictures. Do you like pictures? I like pictures. Here's Northwest Vista College, all right? You've got students that are going to transfer over to UTSA, right? And within that group, you have the biology people. That makes sense? Okay. 30% of students at Northwest Vista College transfer to UTSA. All right? So the number of students that go from here to here, or the percentage of students that go from here to here is 30%, right? 30% of the people from here go over to here. And then, of those people that go over, only 12% go into biology, right? Only 12% of that group go into biology. So only 12% go into here. So how in the world are we going to do this? Oh, and we also know there are 15,435 students over here at Northwest Vista College. So how could I approach this? I've already heard kind of an approach which I agree with, but starting with that picture, someone give me a way.
You have to divide 0.3 by the other number.
So this one right here. So first thing we can do is figure out how many students are going over first, right? So let's figure out the number of students transferring to UTSA, right? Which is 30%. So that means I need to do 30% of 15,435, right? 30% of the Northwest Vista students are going to transfer to UTSA. So this right here means 0.3 times 15,435. And we do that on our calculator, and we get
404,630.
what? Say again?
4,630.5.
Okay, so this equals this. If you do 0.3 times this, you get that, all right? Now, ignore the fact that you get 0.5. I mean, you don't have half people. Well, it's 2019. You can have a lot of different things. So let's just leave it as a decimal, all right? So of the 15,000 students, roughly about 4,600 of them are going to go to UTSA. Now, these students are not all going to go to biology, right? Only 12% of them are going into biology. So now, to figure out the number of students, number of transfer students, in biology, what we have to do is 12%, so 0.12 times what? That number, times 4,630.5, which equals 5 what? 555?
Yep.
0.66. So we'll again not really care about the decimal. Approximately of the 15,000 students or so that are at Northwest Vista College, we should expect about 555 or so of them to be biology majors at UTSA. Make sense? Okay. So it's almost like we had to do two problems, right, to do this? Let's take a look at the next one. You know what? I think, why is that? There's a difference between number 8 and number 7. Ah, trying to get number 8 right there. Okay, there we go. Number 8 and number 7 are very similar, right? The only difference is what? They don't tell you how many students you start with, right? And they're not asking for the number of students that are going to be going into biology, right? They're not asking how many students wind up in biology. They're asking what percent of students wind up in biology, right? So how can we figure out what percentage? So let me try and do it this way. Remember how we did, how many of you have iPhones, right? And we said you take the number of people who have iPhones and you divide by the total number, right? By the total number. Well, how many students are going over to UTSA and becoming biology majors? This many. How many students were there total? 15,435, right? So if I take that number and divide it by that number, that's the percentage of students that were at Northwest Vista that wound up in biology at UTSA. Does that make sense? So for number 8, what I'm going to do is take the number of the transfer biology students, and I'm going to divide it by the total number of NVC students that we started with. And that will give me the percent of NV students that are going to UTSA and majoring in biology. So that's 5, let's go 555. You can go 0.6, doesn't matter. Over 15,435. And somebody give me that. So you have to have done number 7 to do number 8. You can actually do 8 without 7, but if you do 7, 8's easy, because you just take this answer, divide it by that. So somebody give me that. What is it?
0.036.
So 0.036. And if we convert that to a percentage, what do you get? This is, 3.6%. Y'all okay with that? So out of all of the students at Northwest Vista College, you should only expect about 4, good enough? 3.6%, about 4%? 4 out of every 100 people are going to be at UTSA doing biology. Does that make sense? Now, I wonder, could we have gotten that answer 3.6 without knowing anything other than the percentages? Watch this. We had what percentage transferred over?
30.
30, right? And then what percentage of that group went into biology? 12. What happens if I take those and multiply them?
You get 3.6.
If you multiply 0.3 times 0.12, you get 0, same answer. So what I'm getting at is, if all you know is the percentages, if you multiply the two percentages, then you get the same answer, and it's not a coincidence. That would happen every time. All right? That's just FYI. All right? All right, moving on. How are we doing on time? 10:20? We're good? Okay. Let's proceed here. Number 9. What? What is this? Okay. In a Gallup poll, 976, I thought it said students, 976 adults, 68 said they drink alcohol every day. What percentage of respondents who said, what is the percentage of respondents who said they have a drink every day? This one's pretty straightforward. What are they asking you to do? Is it not straightforward?
No, I'm saying that's a weird question.
Yeah. So we want to know the percentage of respondents who said they have a drink every day. So that means we want to take the number of people who drink every day and divide it by the total number of people that were in the poll, right? 976. So 68, divide that by 976. What is that? 0.069, which is about 6.9%. Roughly 7% of the adults that were polled drink alcohol every day. I think that problem was a little bit easier than the last one. Would you say? Yes?
I don't want us to round up.
If you round that to 7%, I'm not going to take off. If you leave it as 6.9, it's fine. So you don't get any less points for rounding that. All right, proportions. So proportions are a little different. Let's talk about proportions. let's see. Does anybody have like any food with them that's like in a wrapped container that has all the nutritional information on it with them? Candy bar? Nothing? Oh, it's okay. I'm just going to ask you to read something to me. All right? Is that like a bar of something?
Yes.
Can you tell me on that bar how many calories are in that bar? 250 calories? So 1 bar of something, whatever it is over there, is 250 calories. Do y'all know what a calorie is? All of our food, they measure it in calories. Do y'all know what a calorie actually is? It's like energy, yes. And energy is actually heat. Believe it or not, energy is heat. So 1 calorie, if you take 1 inch, everyone kind of familiar with what an inch is, right? So an inch, if you take a little cube that's 1 inch by 1 inch by 1 inch, and you fill it with water, all right? And you take its temperature. Let's just say that the temperature of that water, just for the sake of saying it, is 74 degrees. Let's just say that, okay? 1 calorie is the amount of heat it would take to raise the temperature of that water 1 degree. So imagine a little candle under here. You put a little candle under here. However much heat is required to make that 75 degrees is 1 calorie, all right? Now, the calories on the back of are actually, I believe they're kilocalories, but they don't tell us that because it's not that important. So it's actually, I may be wrong there, but I'm pretty sure it's kilocalorie. It's 1,000 of those. So when you see 250 calories, it's actually the amount of heat to heat up 1,000 of these blocks by 1 degree. I'm just telling you because that's what a calorie is, and it's heat. And heat is energy. We move, right? You move your body, you get hotter, you run, you get hot. That's, you're burning calories. All right, so you eat 1 bar, right? And it's going to put 250 calories into your body. My question is, let's say that I'm watching what I eat and I only want to consume 400 calories, right? Let's say I only want to consume 400 calories. How many bars can I eat? Do you all understand the question? So I want only 400 calories. How many bars can I eat? So this is where proportions come in, okay? Proportions, and that's what this next section is about. A proportion is any 2 quantities that are connected to one another through an equation. So you know how we said 1 bar is 250 calories? When I write that down, I can write it as an equation. 1 bar equals 250 calories. Now here's the important part. Since this is an equation, I can divide both sides by 250, right? Or I could divide both sides by 1. It's my choice because it's an equation. I'm going to do both of them. So watch. There's 2 different options I could get from this. I could leave this here. I could take all of this and divide it through, which means I would have 1 bar over 250. I'm going to put cal for calories. Is that all right? Or if I did it the other way, I could have left the 250 over here and divided through by 1 bar. And what we have from this equation, we have 2 what we call proportions. And you can use this one or this one. This is saying that 1 bar, there's 1 bar, there's 1 bar, 250 calories per bar. This one's same thing, just reversed, right? 250 calories per bar, 1 bar per 250 calories. Now, let's answer my question. I want only 400 calories, right? How many bars can I eat? So what am I trying to find? What am I looking for? The number of bars, right? I'm wanting to know how many bars, right? How many bars? So the way I'm going to do this is I'm going to look at these two proportions, and I'm going to choose the one that has bars on top. Okay? See, bar here? And what I'm going to do is this. I'm going to take 1 bar over 250 calories, and I'm going to set it equal to another equation, okay, like this. 1 bar over 250 calories is equal to bar over calorie. Now, I'm given what in this problem? I only want to consume 400. So I'm going to fill this with 400, because that's what I'm trying to consume, and I'm going to put X up there for the number of bars. And then I'm going to cross multiply. Although you don't, yeah, the thing is, you don't need to cross multiply because you don't need to do 250 times that. Like, you don't need that part because you just want X by itself here, right, everyone? You just want X? So what about just multiplying this side by 400 calories and multiply this side by 400 calories? Let me do it, but I want to make sure before we actually do any math that we understand the setup. 1 bar per 250 calories, right? It's 1 bar, so that means I can set it up 2 ways. Bars over calories or calories over bars. I'm going to consume 400 calories. I want to know how many bars I should eat, so I use the one that has bars on top. I put that here, and then I put a blank proportion over here with bar over calorie, just like this. X here, because that's what I'm searching for, and the 400 comes from what I'm given. All right? Make sense? Then I'm going to solve for X. So this is where I like this idea. I'm solving for X, right? I like doing this. If I want to get this, right, this is what I would like to know. That's what I'd like to know. So I don't want this here. So I multiply by 400 calories on this side. And I multiply by 400 calories on this side. Make sense? 400 calories on both sides. And then the calories cancel. 400 calories cancel here. The calorie units cancel here. And so what I'm left with on the left side is 400 times 1, right? Bars over 250. So really I'm left with 400 over 250 bars equal X bars. It's bars, however you want to look at it. Do y'all see where that 400 over 250 is coming from? Sure? And now, on your calculator, 400 divided by 250 is what? 1.6. 1.6 bars. All right. So I'm we have 15 minutes left. So true story, and I'm actually going to turn this into a math problem. Okay, so true story. About 2 weeks ago, my daughter, we have a fish tank, little 10-gallon fish tank. She's had it for about 5 years. She's had the same fish in it. Everything's great. We're ready to go to a bigger fish tank. So we moved those fish over to a 20-gallon fish tank, right? And then she's like, Daddy, I want to put some more fish in there. So we went and got some fish, and we put them in there. And then on Friday, she's like, Daddy, have you looked at my fish tank lately? I said, no. She's like, come look at it. So I go and I look, and all her fish have these little white dots on them. Do y'all know anything about that? Has anyone ever had that before? Okay. So it's a parasite called ich. I-C-H, I don't know. Okay? And it's like, here's your fish. Okay? Here's the tank. It looks like someone sprinkled salt on the fish.